This is the Bambulab H2C, this is my unsponsored review, and this was my face after testing it for 2 weeks. Not because the H2C was particularly good or bad, but because the hype at Formnext and the actual community reaction barely match up. Too expensive, too slow, wrong concept. I've read this criticism a lot over the past few days. To find out if the criticism is valid, I tested its hard and software, compared it with my Prusa XL and discovered something. The target audience that the H2C is really worth it for isn't the audience Bambulab addresses in their marketing. Hi, my name is Niels, you're watching Perspective 3D, and since this probably isn't the first H2C review you are watching, I will skip the long unboxing and endless technical details. Because the unboxing was, as with every 3D printer from Bambulab so far, straightforward and pretty unremarkable. At least until the first startup of the Vortex system. Remove packaging material, loosen a few screws, connect the AMS, and then just follow the instructions on what is probably the best display for consumer 3D printers. The design of the devices and the easy operation are Bambulab's trademark and one of the reasons they've been able to conquer the market in such a short time. With the H2C, the Vortex system is obviously the highlight, and that moment when it moves for the first time, anyone who feels tech knows exactly what I mean. Unfortunately, Bambulab went with side panels made of plastic even on their flagship model, and not aluminium like they used to on the X1C. Even though the sides are kept dark and the housing material isn't crucial for printing, I would have appreciated it at least for the top model. The door and front window, on the other hand, are made of real glass and fit absolutely perfectly. All manufacturers could really learn from that. The Bambulab logo is even illuminated in the side window, and these are exactly the little details that create the premium overall impression. The Vortex system itself naturally increases complexity and potential error sources through its mechanics. But even during setup, you notice how quick and yet precise the changes are. Let me say this up front, during my roughly 2-week test, I didn't have a single problem that was attributable to the Vortex. The unboxing and commissioning show pretty well why Bambulab is so popular, despite some points of criticism I will get to. Despite the many steps required for calibration, almost everything runs automatically. You don't have to worry about anything and have the printer completely ready to operate in under an hour. But what good is the prettiest printer if the results don't work out? And to find out how the H2C really performs, I put it through different tests against my Prusa XL. The Prusa XL is, just like the Snapmaker U1, a classic tool changer, and thus the device the H2C is currently most often compared with. Anyone who wanted uncompromising multi-material printing had to go with the Prusa, and now Bambulab is targeting exactly this segment. But before we start the print test, we obviously have to slice. And this is exactly the right moment to look at the integration of the Vortex system into Bambu Studio. And as far as the slicer goes, currently no choice other than Bambu Studio, because the H2 series isn't yet supported by Orca Slicer at the time of this video. Vortex naturally also brings more complexity into play in the slicer, because unlike the Prusa XL, the Snapmaker U1 or the upcoming index system for the Core 1, with the H2C, the tool, meaning the nozzle, isn't permanently bound to a specific filament. Instead, the filament is pushed through the AMS into the nozzle after switching the tool. And this means the slicer can decide which filament is combined with which nozzle. And especially when you're printing with more filaments than available Vortex nozzles, it makes sense to group light and dark colors, for example, on different nozzles so less purging is needed. At first glance, all this seems pretty confusing, and it is when you deal with it for the first time. But after a few sliced and printed models, you pretty quickly understand how Bambulab envisioned the workflow. In principle, it works like this. You first synchronize the printer with Bambu Studio. Then all filaments and nozzles are automatically assigned correctly. Alternatively, you can also create the configuration manually if you want to prepare a print while the H2C isn't connected. Then you can color your model, and before starting the print, it's automatically checked which of the currently loaded colors makes the most sense and which nozzle is suitable for it. Bambulab has really put in a lot of work in the slicer to take as much as possible off your plate. And this is only possible because the AMS knows where which filament is loaded and also the vortex system through the chips in the nozzle is always informed about what each nozzle can do and which material was last printed with it. From my perspective, this is a huge advantage over Prusa Slicer, for example, especially with a view to the upcoming index system. With the XL or the Core 1 with MMU, it's currently the case that you have to remember which filament is on which position and manually assign it on the printer before starting the print. Simply sending a file and starting to print without having to intervene on the display on site only works if everything is loaded exactly as it was set in the slicer. With Bambu Lab, the integration between hard and software is just so much better that I hope Prusa still works on this before the index system launches. My verdict on the software is therefore set, and now I was more curious whether the print quality of the H2C also convinces or whether perhaps the Prusa XL has the edge here. For my tests, it's important to me to deliver you reliable results in 3 categories: the performance of the cooling system, the dimensional accuracy of the prints, and the resolution of fine details, each with 2 and 5 colors. My first test is the Scandic plate. This is an extreme overhang test without support material that shows how well part cooling works on the printer, but also how intelligently the slicer chooses the strategy for such overhangs. And I was honestly surprised. Even though the Prusa XL is already about a 5-year-old platform, and I've always had the feeling that the part cooling is somewhat weaker than on newer printers, the result from the XL actually looks a bit better than the H2C. Specifically, in the food area, the layers don't adhere completely on the H2C. And that even though the H2C has, in addition to its fan on the printhead, the external part cooling fan in the housing that blows on the model from the side. First point therefore goes to the Prusa XL, although I think you can still tweak the settings to improve the result on the H2C. In the second test, I now check how fine details and gaps between printed parts are represented. For this, I selected the all-in-one test from Meister Edel. I prepared it in Bambu Studio and in Prusa Slicer, each first with 2 colors so that both the Prusa and the H2C have to change nozzles. This way the test also shows whether the nozzles are cleanly aligned with each other. The print time is nearly identical for both devices, which is also logical because Bambu Studio suggests distributing the 2 filaments on the right and left nozzle. This is why the printhead can switch quickly between the 2 nozzles without bothering the vortex system every time. In the result, the H2C and the Prusa XL are really very close together. Starting from a gap of 0.15 mm, the pin and moving elements are free moving. On the H2C, even the rocker with 0.1 mm tolerance already works. The text is displayed slightly sharper on the H2C, even though both printers printed with the standard 0.4 mm nozzle. But the same filament shows a bit more stringing on the H2C. As for the small peaks, these are a bit cleaner on the H2C, and here the cooling seems to grip a touch better than on the XL. Of course, you can recalibrate on both devices if you want, but what is important to me in such tests, how good is what a user gets out of the box. Not everyone wants to endlessly tweak profiles, many are happy when it just works right away. The fact that both devices are so close without special calibration shows, on the one hand, that Prusa has been doing a good job for a long time, on the other hand though, that huge leaps in pure print quality just aren't possible anymore today. Overall, the H2C delivers a very good result, even if it doesn't open up a completely new league in print quality alone. But maybe in the third test, where I compare the absolute accuracy of both devices with the so-called cauliflower. So I will answer the question, if I print a 100 mm object, does it really come out of the printer at 100 mm? And for this you print this test model, then measure 10 defined positions and enter these values into an online tool. The result is 3 numbers: the deviation from the target value in X direction, the deviation from the target value in Y direction, and the perpendicularity of the 2 axes to each other. The advantage of this method over classic calibration cubes is that filament flow calibration has no influence on the measurement result here. Stefan from CNC Kitchen made a very good video about this, which I will link below. In my tests, I achieved absolutely usable results on the H2C both with the standard nozzle and with the Vortex nozzle. My Prusa XL performs somewhat worse in all 3 values, which might also be because it's no longer a new device and already has quite a few operating hours under its belt. Should the values get worse over time on the H2C, you can additionally use the vision encoder plate already known from the H2D and H2S for recalibration. This allows the printer to automatically check its kinematics again using a special pattern and thus improve or at least restore dimensional accuracy. I haven't done a test with this yet, but if you look around Reddit, the differences apparently aren't quite as spectacular as the marketing promises. Drop me a like and a comment if you'd like to see a test on this. Bottom line, the H2C in my free test is somewhat better, especially on the topic of dimensional accuracy, compared to the Prusa XL. But why is there still so much criticism of the H2C? Well, let's now have a look at what happens when we bring more than 2 filaments into play. Because now the Vortex system really comes into action. On paper, it sounds like the perfect solution for fast multi-material printing. After all, the H2C actually changes nozzles in seconds. In practice, the H2C is still significantly slower than printers that change the entire printhead when multicolor printing. If you compare the same 5-color print on the H2C with a real tool changer like the Prusa XL, the difference becomes very clear. The H2C takes around 4.5 hours in my test, while the Prusa XL would be finished after about 1 hour and 45 minutes. The H2C's problem is that it only has a single filament path via PTFE tube towards the Vortex system. This means with every material and nozzle change, the filament also must be retracted from the AMS and then the new color fed back up to the nozzle. The longer the PTFE tube, the longer this takes, in the worst case around 45 seconds per change. A small but effective trick is therefore to keep the tubes as short as possible, and this sounds trivial, but really saves print time in the long run. Material savings with the H2C is also only maximized when a separate Vortex nozzle is used for each color in the print. Unlike the other Bambu Lab printers, there's no endless purging then, but just a small amount of filament is enough to prepare the respective nozzle. That's also the reason why this purge tower still appears, but it's significantly lighter than the waste that occurs with classic AMS setups. This makes clear where the actual weak point of Vortex in combination with the AMS lies. The individual change times add up extremely on complex prints. You might think that Bambu Lab has maneuvered itself a bit into a dead end with the strict AMS dependency for multicolor printing. But there are also 2 arguments that speak in favor of the combination of Vortex and AMS. First, Bambu Lab doesn't have to worry about how to elegantly route a whole bunch of PTFE tubes into the housing. All tool changers and also the upcoming Core 1 with Index need a lot of space at the top to ensure filament feed to each tool. Accordingly, the housings are usually huge towards the top and look rather functional. With Bambu Lab, you simply place the AMS on top of the printer, everything is enclosed and looks significantly neater. Second, and this is the more important point, with the Vortex system, the number of simultaneously loaded filaments can be larger than the number of available nozzles. You can permanently have up to 25 filaments on the printer with multiple AMS units. With the Prusa XL, it's actually limited to 5 loaded filaments. And swapping individual filament also goes faster on the H2C than with other systems, since I just push the beginning of the filament into the AMS and don't have to wait until it's fully loaded. That takes much longer on the Prusa XL and surely also on the Core 1 with Index. Now, despite all the points in favor of the AMS, there's one scenario that will give you some real headaches. And if this matters to you, you should seriously think about whether the H2C is actually the right choice. I'm talking about printing flexible filaments like TPU on the H2C, and this is where the system just doesn't work for me. Since the H2C is based on the H2D, it also has inherited its integrated filament buffers. What used to sit on the back of the printers with AMS is now integrated in the device. In itself, a good thing, but neither the filament buffer nor the AMS work with soft filaments like TPU. And that's why Bambu Lab has provided a bypass for the right nozzle through which you can manually push TPU past the buffer directly into a Vortex nozzle. And this makes it possible to print TPU on the H2C. But this partially undermines the actual principle of Vortex. The system can still change nozzles, but you would have to manually change the filament for every other material you want to combine with TPU. As an alternative, you can switch the freed up AMS to the left nozzle, of course, and combine a TPU with more than one other filament. But then you have the waste mountains again because the rigid left nozzle obviously has to be purged when changing filament. The better workaround is loading TPU on the left non-vortex nozzle. Officially unsupported, but it works if your TPU is 90A or harder. You then can even print with 2 different TPUs in one job, except you've got to pop off the top cover because there's only one bypass on the back. For a printer in this price range and for a company that tries to make 3D printing as easy as possible at every turn, this is honestly frustrating. That I have to switch the AMS and that the Vortex system is basically hardly usable for this use case wasn't clear to me in this consequence when ordering. Especially the combination of flexible and rigid filaments opens up exciting applications, as I showed in my video on P-bar filament. And this is exactly where the H2C is simply not competitive. For me, it's therefore not an uncompromising multi-material printer, as Bambu Lab's advertising promises. Add to that fact that the Vortex system, while faster than previous Bambu Lab AMS setups, is slower than other tool changers, and this explains pretty well why many are disappointed with the H2C. A Snapmaker U1, for example, which costs less than half, is not only faster in such scenarios, but you can also meaningfully combine multiple flexible filaments. But reducing the purchase decision for or against an H2C only to multicolor printing and TPU can, however, depending on the use case, also lead you in a completely wrong direction. Because in the last section of my review, I will show you where the H2C's really strengths lie and how Bambu Lab should have actually positioned it from my perspective. At its core, Vortex isn't a big revolution in multi-material printing, but more like an AMS for nozzles. And when you look at it that way, suddenly a lot more makes sense. When the AMS came out on the market, everyone was excited about easy multicolor printing, but just as quickly disillusioned by the huge waste mountains. So why did AMS and Bambu printers become so successful anyway? Because the actual added value isn't the colorful prints, but the massive comfort gain. I always have multiple filaments in the printer, can store them dry, and simply select via app, if necessary even remotely, which material I want to start the next print with. I personally use the AMS much more often as convenient integrated storage than I use it for the actual multicolor printing. And this convenience is exactly what the H2C transfers to nozzles with the Vortex system. First print with a standard 0.4mm nozzle for PLA, then a tabletop figure with the fine 0.2mm nozzle, and then a robust part with 0.6mm. That's been possible by hand so far, but you have to walk to the printer, wait until the nozzle has cooled down, old nozzle out, new nozzle in. With Vortex, all of that is eliminated. You simply select the appropriate nozzle in the slicer, the printer takes care of the rest. I can well imagine that this is relevant for more users than you would think at first glance. And as it is often the case with comfort features, once you've gotten used to it, you don't want to give it up again. And there's another aspect that comes up too short in some reviews, namely the H2C's capabilities that have nothing to do with the Vortex. I'm talking about printing functional parts and challenging filaments. Materials like ASA, polycarbonate or nylon aren't as easy to print as PLA, but are needed when your 3D print needs to withstand higher temperatures or stronger loads. At its core, the H2C is nothing other than an H2D with Vortex on top. And the H2 platform was designed from the start to print challenging materials stably and with minimal warping. The actively heated chamber reliably brings the build space up to around 65 degrees Celsius. And that's a real difference from printers that only heat up through bed waste heat. Snapmaker U1, Prusa XL, and also the Core 1 don't have a comparable actively controlled chamber heating in this form. Now, for testing, I distributed small ASA prints that strongly tend to warp across the entire print bed. While I had significant warping on the corner parts of my Core 1, despite sufficient heating time, all the parts on the H2C, despite the larger print bed, stayed absolutely flat. Both build plates were properly cleaned. I deliberately avoided additional adhesion aids like glue sticks. Some testers have shown uneven heating of the H2C print bed with a thermal camera. In my test, this at least didn't have a negative effect. Other filaments like polycarbonate could also be printed almost without warping and without special tricks and aids. The same print on the Core 1 only stuck to the print bed with adhesive and had large cracks after printing. In my opinion, it's more the overall package that makes the H2C so appealing. since you don't get all these features in one package from any other manufacturer, and especially not at this price. The high nozzle temperatures up to 350 degrees Celsius, both on the standard nozzle and on the Vortex side, are a real advantage for more advanced filaments. With Prusa, for example, it stops at just under 300 degrees. A high temperature hot end up to 400 degrees Celsius was recently introduced, but that's designed for the normal extruder and not for the index system. It's also not supposed to be compatible with the Prusa XL according to the current status in the shop, which means there probably won't be a multi-tool Prusa printer that can print at higher temperatures than 300 degrees Celsius in the future. The SnapMaker U1 doesn't even try to be a printer for these technical materials, which is completely fine because the device is clearly aimed at different target audience. When you look at the H2C this way, for $2,399, you currently get an extremely versatile printer with which you can print almost all common filaments from PLA to challenging technical materials without any problem. Plus maximum comfort thanks to AMS and Vortex, excellent integration of hard and software, and compared to pure AMS setups, also significant material savings and some time gain when multicolor printing. The price is of course a bitter pill for everyone who bought the H2D earlier this year for the same money. The upgrade kit for well over $800 doesn't help there either. I would even go so far as to say that the H2C is actually almost too cheap for the overall package. And that Bambu Lab clearly wants to gain even more market share. But part of the truth with Bambu Lab is also you're buying into a closed ecosystem. You can use any filament in the H2C, but with the Vortex nozzles, Bambu Lab blocks third-party hot ends through the integrated chip with the argument of safety. From my perspective, everyone has to decide for themselves whether they want to accept this. It's important to me that you know this before buying. The price per Vortex hot end at around $40 for the hardened standard version is reasonable. Nevertheless, I would have wished, if only for availability reasons, that other manufacturers would also be allowed to offer corresponding hot ends. Bottom line. If you only measure the H2C by how quickly it prints multicolor models, it seems like a rather poor compromise. But as soon as you see it as a tool for technical materials, with active chamber heating, high temperature and very good mechanics, the picture changes completely. Then it's suddenly no longer the disappointing multicolor printer, but one of the most versatile printers in its class, except for printing TPU. Thanks for watching the video, for your comment and support through subscribing. It's really incredible how many subscribers this channel has by now. And if you want to watch more videos about 3D printers, then click here now.